Hi, in this video we discuss Archimedes principle. Archimedes principle. We restate basically Archimedes principle. So how do we state Archimedes principle? This principle, it states that when an object is totally or partially immersed in the fluid or liquid, it experiences an upthrust which is equal to the weight of the fluid displaced. So basically we can say that the upthrust of the object is equal to the weight, of the fluid displaced. This is what Archimedes proved. So basically to describe this principle, we will consider the following scenario. Assume we are having the container or the beaker which is full of water. This is the container which is full of water, and basically the pressure of this water, it depends on height. As the height of the water increases, even the pressure increases. And as we know that pressure is given by force divided by area, and force is obtained by taking mass of the body times the gravitational force. So you can write that pressure is equal to mass times gravitational force divided by area. But what is mass? Basically mass can also be obtained by taking mass is equal to density of water, because here we are talking of the fluid which is water, times the volume of the water. So now we can write pressure, this is equal to mass, it is density of water times the volume of water times G divided by area. And what is volume? This volume of water sometimes also can be obtained by taking the cross-section area times the height. So we can substitute this value here and write pressure is equal to density of water times the volume of water, which is area, times height times G divided by area. So area and area cancel out. So we can write that pressure is equal to density times height times the gravitational force, which is sometimes also written as rho times G times height. So because density and gravitational force, they are constant, we can say that pressure is directly proportional to the height, so long as density and gravitational force, they are constant. So as you increase pressure, you increase the height. As you increase the height, you increase the pressure. As you decrease pressure, you decrease even the height. So also, let us take another scenario. For instance, we are having the same beaker. This is the beaker, and of course it is full of water. And assume we take the plastic material. For instance, we can take even the cylinder. This is for instance the cylinder, and put it inside this beaker. This is a cylinder. It is basically placed inside this beaker. So we say that, of course, there will be two pressures. We will be having the pressure at the bottom, which is P1, and we will be having the pressure at this point. Let's say this is P2, pressure 2. And of course, let us assume that this pressure 1, it is at the height, which is H1, from the surface of the water. And also let us say from this surface of the water up to this point P2, we are having also another height, which is H2. This is H2. Now the pressure will be large at this point, because at this point there is large height. So if we are having large height, it means even the pressure will be large. So we can write that the pressure at point 1 will be obtained by taking rho times G times H1. Similarly, the pressure at point 2, P2, is obtained by taking it is density times gravitational force times it is height. So it is obtained by taking rho times G times height 2. But in this case, because the pressure will be large at this point, you can write that P1 will be greater than P2, because here the height is large as compared to the height from here to here. So if we find out the difference between the pressure, we can write that basically the change in pressure is obtained by taking P1 minus P2. So this will be equal to, what is P1? P1 is given by rho times G times H1 minus P2 is given by rho times G times H2. So this can be written as, this is equal to, you can write rho times G bracket H1 minus H2. But this H1 minus H2, it is the difference in height between this point here and this point here. So we can write H1 minus H2, this is equal to change in height. So basically we can write that change in pressure now, this is equal to rho times G times change in height. But also we know that the pressure of an object is given by force divided by area. And basically change in pressure, this will be equal to change in force divided by area. So we can calculate the change in force. Now change in force can be obtained by taking, we can take change in pressure times area. But what is change in pressure from this equation here? Change in pressure is rho times G times change in H. So this is rho times G times change, this is change in height, then it times the cross-section area. Alright? Okay. So now you can take, if we take area times the change in height, this is the volume. This is volume. Area times change in height, this is volume. So we can write change in force, this is equal to, it is rho times G, area times change in height, this will be, this is gravitational force, this is gravitational force, times the volume. But also density times volume, this is mass, this is mass. So we can write density times volume, this is mass, but it will be the mass of the water displaced by this container, which is the cylinder. So we can write mass of water displaced times G. So change in force is obtained by taking mass of water displaced times gravitational force. Now what is force? Change in force, this will be the upward thrust because of which this cylinder will exert and it will actually move upward. So this is actually the upward thrust because of which this cylinder will exert and move upward. Now we can say that this change in force, it basically corresponds to the force of which this cylinder will exert the mass of this object, which is the cylinder. So when we can also say that this change in force is given by mass of the object times gravitational force. In this case, mass of the object is the cylinder. So we can substitute here the mass of object now times gravitational force. This will be equal to mass of water displaced times gravitational force. So we can conclude the following. The conclusion can be drawn as follows. We say that the first conclusion is that when the body is totally or partially immersed in the fluid, the weight of an object, this is weight of the object, which is the cylinder in this case, will be equal to the weight of the fluid displaced. That is the first conclusion. But also, if you cancel out this gravitational force and this gravitational force, we can also say that the mass of object, in this case it is the cylinder, will be equal to the mass of the water displaced. That is the second conclusion. But also we can write that because mass of object, this is equal to mass of water displaced, and we know mass of object, this will be density of object times the volume of object. This is obtained by taking density of water times the volume of water. We can also draw another conclusion by saying that the volume of an object is equal to the volume of the water displaced. Thank you for watching. Don't forget to subscribe, and see you in the next video.